Whoever you are, however insouciant your inclinations, however disparate your despair. Hello. The time has come to face a few apocalyptic facts of our existence here on Earth. Actually, the time has already come and gone decades ago. Still, the second best time to act is always now. That said, I have been putting off this episode of Wiggle Soup for no other reason than it is tragic. The impact that human beings have had on this planet is mortifyingly, gut-wrenchingly awful. But that's why it warrants so much of our attention. We can ignore it, deny it, assume it's inevitable, or just talk about something else, and then fully deserve our complete eradication as a species. Or we can try to make amends, do everything we possibly can to retain a splinter of integrity, even if our fate is already sealed. Whether you think the future is bleak, or can still find some rosy-cheeked optimism to hold on to, there can't be many worthier causes than looking after the planet. Mass extinction. What does that actually mean? How bad can it be? For a single event or period of time to qualify for mass extinction status, at least 75% of the total number of species on Earth have to be eradicated within a few million years. Just a wink of geological time. This kind of ruthless pruning of the tree of life and the subsequent extreme reduction in biodiversity will cripple every ecosystem on the planet. Restoration to previous times will be impossible, and a permanent change will have occurred. Biodiversity, therefore, is essentially a measure of the environment's resilience to disruption. The less diversity there is among species, the slower life can recover, if at all. Today there are about 9 million or so species on Earth total, which includes all the animals, fungi, and plants. Every life form on the planet can be investigated, identified, and categorized according to its biological traits. These categories range from the very broad to the very specific. But we don't need that many of them. The 7 main ones that we should be aware of are kingdom, phylum, class, order, family, genus, species. I didn't need to Google that. It's fairly easy to remember with the mnemonic King Philip came over for group sex. Though I did have to look up the word mnemonic.
Mnemonic?
The earlier groupings on this list, like kingdom and phylum, contain more members and therefore more diversity. These are the bigger boxes that contain lots of the smaller boxes, containing chunks of the tree of life. By the time you've nailed something down to species level, you're talking about one very specific type of thing. Say a European rabbit. Genus Oryctolagus, species Caniculus. I mention this because we need to remember which groups are larger than others in the nested hierarchy. If the family Leporidae went extinct, we'd lose about 70 species of cute fluffy things. If the order Lagomorpha went extinct, we would lose all rabbits, hares, and pikas combined. The next level up is class Mammalia, around 6,500 different species divided into 29 different orders. Just ask yourself, what might it take for all mammals to die off? Every life form, wherever it lives, has a certain tolerance for changing conditions. Some are highly sensitive to factors like heat, water salinity, light intensity, or pollution, dying at the drop of a hat, which is an occupational hazard for some rabbits. Many organisms are a bit hardier and can take more punishment than others, but all have their limits and can be affected by the speed at which a change occurs. Keep that in mind. It's often pointed out that 99% of all species that have ever existed have already gone extinct. This is true and natural and healthy as far as our planet's biosphere is concerned. What needs emphasizing, though, is that these extinctions don't always happen at a constant rate. During a mass extinction event, of which there have been about 11 in Earth's history, a wide diversity of species disappear rapidly, right across the globe. It is fascinating to consider that everything alive today, every bird, every tree, and every insect, is descended from survivors that have made it through all previous mass extinctions, including Homo sapiens. But to wrap our heads around just how bad these mass extinctions were for life on Earth, let's take a look at some numbers around the 5 most catastrophic events ever. The first mass extinction of multicellular life is known as the Ordovician extinction. This happened around 445 million years ago. At this point in Earth's history, most of life was confined to the sea. There were no terrestrial animals to suffer because they hadn't climbed out onto land yet, but a whopping 86% of all species in existence were lost in a very short amount of time. This includes 60% of all marine genera and 27% of all marine families. Acidification of the oceans during this time caused 2/3 of all invertebrates to perish. Basically, anything that needed to build a shell couldn't. Creatures like clams and starfish, corals and trilobites barely made it through the bottleneck. The cause of this extinction event seems to have started with widespread glaciation, with the expanding ice sheets cooling the planet and reducing sea levels. The resulting oxygen depletion swung the process into reverse, causing the glaciation to recede and warm conditions to abruptly return. Evidently, this was just too much for most of early multicellular life. Next came the Devonian mass extinction about 360 million years ago. This time, half of all genera and 75% of all species copped it, the minimum requirement for mass extinction status. Again, marine life took the worst hit, but spiders, scorpions, and all the pioneering proto-amphibians knocking about on land also paid a heavy toll. What caused this event is still something of a mystery, with giant volcanoes and asteroid strikes being suggested. In either case, the sea levels dropped once more following widespread cooling and glaciation. Plants, which were absolutely dominating the land at this point, made the global cooling even worse by continually absorbing carbon dioxide from the atmosphere. It would take corals over 100 million years to recover from this trauma. Third, around 350 million years ago came the Permian extinction. Oof, this was a bad one. The Great Dying, as it's affectionately called. Following a series of massive volcanoes erupting in Russia's Siberian traps, huge amounts of carbon dioxide were emitted, raising global temperatures and exterminating around 96% of all species on Earth. Ocean temperatures warmed to over 40 degrees, causing 53% of marine families, 84% of marine genera, and 95% of all marine species to perish, including the trilobites. 300 million years those guys stuck around. Anything that can take out trilobites must have been apocalyptic. It was the Triassic period around 200 million years ago that felt the next mass extinction, Volcanoes ruin the party once again, showing many early land animals the door, including therapsids, archosaurs, and many large amphibians. But the dinosaurs held out. Before those awesome reptiles could rise to power, 80% of all Earth species were wiped out, including 48% of genera and 23% of families. Sucks! The fifth of the worst mass extinctions is perhaps the best understood, and more widely talked about than any other. About 65 million years ago, at the end of the Cretaceous, a 10-kilometre wide asteroid touched down, ending the dinosaurs. But those hit by the fireball were not the only ones affected. The impact killed half of all genera and 76% of Earth's plant and animal species. Having penetrated the planet's crust, casting an unimaginable amount of dust and vaporized rock into the atmosphere, the impact caused perpetual darkness to fall across the globe. Such a rapid loss of light and heat dragged the extinctions out for millennia. So what can we learn from all this? What patterns can we see in the mass extinction data? A few reoccurring features are the glacial advance and retreat, sea level rise and fall, and global temperature change. This tends to be way more severe than a mere ice age. Planet Earth experiences ice ages quite routinely in cycles of about 100,000 years or so. No doubt many species will feel the pinch, dying out locally or globally, but the change tends to be gradual enough that most species can adapt or migrate. Our own species certainly made it through an ice age which ended about 20,000 years ago. Mass extinctions are different, far less regular, and much more pronounced. The Big Five seem to be linked by fluctuating ocean currents and oxygen levels and the amount of carbon dioxide in the atmosphere. This contributes to all of those global temperature and sea level changes while turning the oceans to acid. You don't need me to tell you that all of these things are happening in the world right now. The monumental amount of carbon dioxide that humanity throws into the atmosphere each year is causing global temperatures to rise and oceans to acidify. Human activities are changing the planet radically and fast. The rate at which global biodiversity is currently being lost is greater than in the years immediately after the impact that killed the dinosaurs. That event took millennia to reach mass extinction status. With the possible exception of the first oxygen-breathing bacteria, no living creature has ever changed the climate of Earth as dramatically as we have. But hold on, I hear you cry. We haven't lost 75% of all life yet. Why insinuate that we're causing the sixth mass extinction? Well, because that's exactly where we're headed, and the change is accelerating, not slowing. To see how we're doing this, I've poached the acronym HIPPO, possibly from Jared Diamond or E.O. Wilson. I'm sorry, I can't remember. HIPPO lists, in order of severity, the worst ways that human population growth, resource consumption, and global travel are negatively impacting our planet's biodiversity. To keep with the theme of impending dread, let's take these in reverse order. O. O is for over-harvesting. If something is profitable, including but not limited to animals themselves, we develop an insatiable taste for gathering it and finding more efficient ways to do so. Whenever demand outstrips supply, the value of a resource goes up. Standard economics. Targeted hunting, gathering, mining, fishing, and the incidental damage that these practices cause inevitably decimate wild populations faster than they can reproduce. Legal restrictions are pretty much the only way to manage this, on top of continued efforts to educate people. We need to shift our values and support policymakers in making sustainable changes. But this takes time, and legal barriers often increase the demand for a product, which tempts people to break the rules. Whales, elephants, tigers, tuna, sharks, and many other key species continue to be purged despite protective measures. On to P. P is for population of humans. Each and every member of our species takes up space. We need food, water, housing, power, transportation, gardens, retail outlets, etc. to live our modern lives. Every additional soul puts more pressure on industries to supply these things. Freshwater availability, soil depletion, reduction in insect pollinators, droughts, crop failures, and land shortages all oppose us. And the energy that people burn throughout their lives to heat and cool their homes needs to be generated from some kind of fuel. And then there's the insurmountable quantity of garbage that we all produce. Our obsessions with fast fashion, disposable goods, and overpackaged products are having disastrous environmental effects. Today there are around 8.2 billion people on Earth, a number increasing exponentially year after year, and we're currently consuming resources at 1.7 times the rate that Earth can renew them. If humanity doesn't slow its multiplication and dramatically change its lifestyle, by 2050 we'll need 3 entire planet Earths to meet our needs. This is clearly not sustainable. The next P is pollution. Worse for the planet than the number of human beings are the industries that we rely on once we're here. Chemical waste that enters the water from a manufacturing or agricultural process savages biodiversity by killing species, weakening them, or adversely affecting an individual's ability to reproduce. These don't have to be synthetic. Even natural substances can be polluting if they're concentrated enough. Fertilizers, for example, washed into waterways cause eutrophication, an explosion of toxic algae that eventually decompose, resulting in uninhabitable dead zones. By blocking sunlight, algal blooms will prevent the photosynthesis and oxygen generation of aquatic plants. Animals in these areas then have to clear out or suffocate. Carbon dioxide is another natural component of the atmosphere, but it significantly contributes to global warming and air pollution when released through human activities. When atmospheric carbon dioxide dissolves in water, it falls back to Earth as acid rain, which is bad news for everybody. When it dissolves in the oceans, well, you can see the problem. I is for invasive species. What could be worse for biodiversity than pollution? When an animal, plant, bacteria, virus, fungal spore, or other microbe finds itself somewhere it shouldn't be, ecosystems can be thrown out of balance. Invaders prey upon local populations, compete with them for food and space, modify habitats, spread disease, and disrupt communal interactions. Since the supercontinent Pangaea split apart, life on the world's various land masses has been evolving and diverging in different directions, in relative isolation. Now, globalized human traffic unintentionally moves creatures around all over the show. In effect, we're slamming all the continents back together again, bringing divergent species into conflict. Sometimes, perhaps most of the time, stowaways just die off quietly. But a small percentage of invading plants and animals manage to naturalize and run riot, released from the population control of their own predators and diseases, having catastrophic effects on the natives of that region. And finally, H. Habitat loss. This is the greatest threat to biodiversity of all. Many species have a very limited home range. Through agriculture, fishing, mining, urbanization, deforestation, water extraction, and, of course, climate change, human activities convert usable habitats into unusable wastelands. The green spaces that remain tend to be too degraded or fragmented to support large amounts of wildlife. Obviously, different animals experience different levels of risk, but wherever the death rate for any population is higher than its births, numbers of that species go into decline. The availability of suitable habitat is central to every life form and every ecosystem. Focusing on singular iconic species like gorillas and blue whales doesn't highlight the real problem: the loss of entire ecosystems. Famous and conspicuous endangered characters like tigers, polar bears, rhinos, and elephants are important and definitely worth saving, but they are not holding ecosystems together. And notice how the world's favourite creatures are overwhelmingly large, charismatic mammals. A shameless bias if ever there was one. Historically, when not faced with a mass extinction event, one species of mammal normally goes extinct about every 700 years, an amphibian every 1,000 years. Today's figures suggest that mammals are going extinct 1,000 times faster and amphibians over 45,000 times faster than is normal for Earth's history. As a global average, species on Earth drop off at around 5 per year. The highest estimates of extinctions today are, wait for it, 100 species per day. Even the lower estimates landed around 1 species per day. All of these numbers are probably underestimations, as so much of life on Earth remains unknown and therefore overlooked. So how long before we reach the 75% total biodiversity loss that defines a mass extinction event? The answer? Between 900 and 2,300 years. This is calculated assuming only the most critically endangered species are lost in the next 100 years. If every species currently under threat is lost in the same time, it will take only 240 to 540 years for Earth's total species to be reduced by 75%. Between housing development, animal agriculture, fast fashion, overfishing, climate impacts, and pollution, humans have done a thoroughly good job of screwing up the planet. Invertebrates, which account for about 97% of all species, have already declined by 45% worldwide. We, with our smartphones and our dietary excesses, are obliviously squeezing the life from this planet 100 to 1,000 times faster than the 5 greatest mass extinction events to date. This is why it's accurate to say that we're not just living through a 6th mass extinction, we're causing it. The evolution of Homo sapiens has been worse for life on Earth than any supervolcano, asteroid strike, or other natural event in biological history. Well, that was a cheery one. Next, I want to talk about how we got here, at which point things spiraled out of control, and what we can yet do to make amends. A quick history of Homo sapiens' relationship with the environment. Learning how it started might help us to stop. That's the idea.
Mnemonic.